Okay, so the first one says WXYZ is a rectangle, and it talks about ZX and WY. So in a rectangle, we talked about this yesterday. What do I know about those two lines right there? What do I know about those two lines? Okay, so in a rectangle, the two diagonals, what do I know about those two diagonals? Okay, they do bisect each other because they're a parallelogram, but there's something even more that we know about those two lines right there. Okay, so comparing ZX, this line right here, and WY, what do I know about these two? They're what? They're congruent. Yes, they're equal to each other. Okay. So we're going to just set them equals 6x minus 4 equals 4x plus 14. Okay, so we're going to subtract 4x from both sides. Let's see, so we get 2x minus 4 equals 14 plus 4. 2x equals 18 divided by 2. And x equals 9. Now this says to find ZX. So I got to take that 9 and plug it back in. So 6 times 9 minus 4. What's 6 times 9? 54. And then 54 minus 4 is 50. It's 50. Okay. I'm going to skip that middle one. I want to look at the bottom one. So on the bottom one, it says this is a rectangle, and if the measure of angle WXY. So let's talk about this first. So WXY is this angle right here. Good. So in a rectangle, that angle right there always is going to be 90 degrees, what we talked about yesterday. Good. So that angle's 90, and it says that it's 6a squared minus 6. So I'm going to set those equal. 6a squared minus 6 equals 90. Okay, so we're going to add 6 to both sides. So this zeroes out. We get 6a squared equals 96. Then what? Well, let's get rid of the 6 first. So I'm going to divide by 6 on both sides. That way this cancels to 1. And then 96 divided by 6. Is 16. Then how am I going to get rid of this square right here? Yep, take the square root. Square root cancels out the square. Inverse operations. So what's the square root of 16? 4. Is 4. So a equals 4 here. Okay, so today we're going to talk about rhombi and squares. So first of all, what is a rhombi? Well, a rhombi is just the plural form of the word rhombus. So it's like saying rhombuses, but you don't say rhombuses, you say rhombi. But that's all rhombi means, is just many rhombuses. Okay? So that's what we're going to be really focusing on today, is a rhombus. So before we get into those properties, let's talk about a couple things real quick. So going back to yesterday, for a rectangle. Now a rectangle is a parallelogram, so all that's true. But what makes a rectangle a rectangle?
The angles.
Okay, what about the angles?
They're equal.
Good, they're all 90 degree. They're all made right. 4 90-degree angles. Okay, so that's what we talked about yesterday. Today, we're going to talk about what a rhombus is. Now, a rhombus is a parallelogram also. So all the stuff that's true of a parallelogram applies to a rhombus. But there's something that makes a rhombus a rhombus. There's like one key feature of it. What makes a rhombus a rhombus? Okay, and that's what most people think. Most people, think of a rhombus as like a squished square or something like that. And that's maybe kind of true, but that's not really, and you're fine because that's what everybody thinks. But it's an easy thing, but what makes a rhombus a rhombus?
The angles. I don't know.
Okay, nope, it's not the angles. It has something to do with the sides. Yep. Do what?
The way they're slanted.
Okay, you're thinking it's not the way they're slanted. It's something easy. This is not difficult at all. It's something about the sides.
They equal the same.
Okay?
Two are same. They're like two are same. And the other two are the same.
Well, that's just because of a parallelogram. But where you were going before that was good. What were you going to say, Vincent? Okay, they are parallel, and that's because it's a parallelogram. But go back to what Michaela said, because she's right on what it is. What did you say? Right here. What you were saying about the sides. What did you say about them?
They're all equal.
There you go. Okay, so that's what makes a rhombus, is that it has 4 congruent sides. 4 congruent sides. All right, so on a rhombus, all the sides are equal. Bless you. Okay, which, I mean, both of those statements are saying the same thing. I just want you to understand that. In a rhombus, all the sides are the same length. That's what makes it a rhombus. It's a parallelogram, yeah, but all the sides have to be the same length to be a rhombus. And so at the end, we're going to talk about rectangle and rhombus. But for the first part here, I just want to focus on a rhombus and some properties of a rhombus. Now, just the definition of a rhombus, we're going to use this fact that all 4 sides are congruent. We will be using that. But we're also going to use these 2 things right here, these 2 properties of a rhombus. Okay, so here's one property of a rhombus. Somebody read that for me, please.
If a parallelogram is a rhombus, then its diagonals are perpendicular.
Okay, and there's the key word. If it's a rhombus, the diagonals are perpendicular. What does perpendicular mean?
Opposite. Or something like this.
Bless you. Not opposite necessarily.
They intersect.
Yeah, they intersect. That's right, because parallels, like they never intersect. Perpendicular means they intersect, but not just that they cross each other. They have to make a specific angle to be perpendicular. Good. They have to make 90 degrees. Okay, good. So in a rhombus where the 2 diagonals meet, where this and this meet, it's always going to make 90-degree angle in here. So will always be 90 degrees in a rhombus. Okay? Those angles are always 90. So that's one property. The other property we're going to use is this one right here. And this is the one we'll probably use more than anything. And this is the one that kind of trips people up, although it's really easy. People overthink this a little bit, or I don't know what, but this is one that kind of throws people off. Okay, somebody different, read that statement for me, please.
If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles.
Okay, so if you got a rhombus, the diagonal bisects each angle. What does bisect mean?
Splits it in half.
Okay, good. We've talked about this a lot. It means to cut exactly in half. Okay? Cuts it exactly in half. So if it's a rhombus, the diagonal cuts the angles exactly in half. So what that means is this, is like, let's say this angle R right here. Say this whole angle R is 80 degrees. Okay? The whole angle here, this whole angle, 3 and 4 together are 80 degrees. This diagonal right here cuts that angle in half. So how big would angle 3 be?
40.
Would be 40. And how big would angle 4 be?
40.
It would be 40. Actually, let me flip this. So this would be 40. This would be 40 degrees. Okay, now, so let's think about this. So let's go this way. So this is also a parallelogram. So what do I know about these 2 angles right here? This whole angle and this whole angle right here. In a parallelogram, what do I know about these 2 angles right next to each other? They add up to 180. Yep. So if this whole angle is 80, how big is this whole angle right here?
100.
It's going to be 100. All right. It's going to be 100 degrees. And if the whole angle is 100, how big is angle 7?
50.
It's going to be 50 degrees. How big is angle 8?
50.
It's going to be 50. Which, if you think about it, the way a parallelogram works, the opposite angles are congruent. So angle 5 would be 50 degrees in this case. Angle 6 would be 50. Angle 1 would be 40. And angle 2 would be 40. Okay? So, what we're going to do is we're going to apply these three properties, or these three things. We're going to apply the definition of a rhombus, four congruent sides. We're going to apply that the diagonals are perpendicular and that the diagonals bisect angles. Which really, well, yeah. So we're going to use all three of those. So on the first one right here, it says if the measure of angle WZX is 39.5 degrees. And I think this is one thing that messes people up is not really knowing how to read an angle. Okay, WZX. So remember, what is the middle letter in that? What does that tell me? That's the vertex, right? That's like the corner of the angle. We talked about this a long time ago. In fact, probably the first or second week of school. That middle letter is the vertex, where the corner is. So WZX is actually this angle right here. Okay. This is WZX because you got WZX. So it's this angle right here. WZX. It says that this angle is 39.5 degrees. And what it wants to know is for us to find ZYX, which is this whole angle right here. All right. Now, since this is a rhombus, it says it over there, this angle right here is cut exactly in half by this diagonal. So cut it in half, it means this angle and this angle right here are going to be the same. So how big is this angle right here? It's going to be the same thing as this. So this angle right here is 39.5 degrees also. Okay, so both of those are 39.5. So how big is that whole angle right there?
79.
Is 79, just adding those two together. All right? So that angle is 79. Now, what do I know about these two angles right here? Okay, good. They are supplementary. They add up to 180. So if this angle is 79, how big is that angle that I'm looking for?
101.
It's 101. Okay, so this angle is 101 degrees. All right. Next thing there is it says that WX is 8x minus 5, so this is 8x minus 5, and that's WZ is 6x plus 3. So now we're talking about how long these sides are. So this side is 8x minus 5, and this side is 6x plus 3. So what do I know about those two sides? They're equal because remember, in a rhombus, all four sides are congruent. So all four of these sides are equal to each other. They're all equal to each other. So I'm just going to set those equal and find the value of x. So I'm going to put 8x minus 5 equal to 6x plus 3 minus 6x. So we have 2x minus 5 equals 3. Add 5, 2x equals 8. So x equals 4. This one just says find x. Okay, on this next one, I don't want to answer this. I want to add in a different thing here to help you better on your assignment for today. Okay, so what we're going to do here is we're going to say that the measure of angle FBC equals 47 degrees. And what we want to do is we want to find the measure of angle FCB. Okay, write that down real quick on your paper there. The measure of angle FBC is 47 degrees, and we want to find the measure of angle FCB. Make sure you write this down, please. Write that down, what I wrote in red. Okay, so angle FBC. FBC is this angle right here. That's FBC. And like I told you, I want to make that 47 degrees. And what we're looking for is angle FCB, which is this angle right here. Okay? I want to find that one right there. That's what I'm looking for. Okay, I'm just going to zoom in on this so we can just really talk about what's going on here. So remember, in a rhombus, that's what this is. What happens where these two diagonals meet up? What happens where the two diagonals meet? They are perpendicular. So how big is that angle? Well, where the F is, how big is that angle?
90.
This angle is 90 degrees, right? And if I'm looking for this angle right here, if you just think about this triangle right here, okay? You just think about this triangle right here. Actually, I'm going to do it like this. No, I'm going to do it like this. Okay, so in a triangle, what do the three angles add up to?
180.
They add up to 180, right? So I know that this angle right here is 90. I know that this angle is 47. How am I going to find this one over here? Yep, so I'm just going to do 180 minus 47 minus 90. And how big is that angle going to be? It's going to be 43 degrees. That's right. Okay, so that answers the question I wanted to do right there. Okay, on this last one right here, BC is 4x minus 5, and CD is 2x plus 7. Okay, if this is a rhombus, what do I know about those two sides? They're congruent, so we're just going to set them equal, solve for x. 4x minus 5 equals 2x plus 7. So x equals 6 there. Okay, I want to look at this and talk about this. We're not going to do anything on the back. I just want to look at this. All right. So what kind of a diagram is this? What do we call this thing?
Venn diagram.
A Venn diagram, okay? Now, what is the overall bigger picture of this Venn diagram? What's the main Okay, so the main thing in this is parallelograms. Everything inside of this whole comparison thing here is parallelograms. So parallelograms is the bigger picture, and we're just going to get more and more specific. So what does it mean to be a parallelogram? Opposite sides are parallel, right? That's what makes a parallelogram a parallelogram. So we're just going to jump in further and further here. So what makes a rectangle a rectangle?
The angles.
Okay, it has 4 right angles, 4 90-degree angles. Okay? What makes a rhombus a rhombus? 4 congruent sides, right? So what happens where these two overlap? What shape is made? A square. Okay? So every square is a rectangle. Okay? But not every rectangle is a square. Because if you think about this, this right here, is this a rectangle?
Yes.
Is this a rectangle?
Actually, yeah.
Well, yeah,
the
because
angles.
it has all the angles.
Yeah, it is a rectangle. Good, because it has 4 90-degree angles. So yes, this is a rectangle. But is this right here a square?
No.
Nope. So that's what I'm saying. Every square is always a rectangle, but not all rectangles are squares. Okay? So a square is a rectangle. Whoops. Okay? So let's think about it in the other way. All squares are a rhombus, but not all rhombi are squares. Is this thing right here a rhombus?
Yes.
Yep. Why is this a rhombus? It's got 4 congruent sides. So this is a rhombus. Is this thing right here a square? No. So every square is always a rhombus, but not every rhombus is always a square. So a square is a rhombus. Okay? So to be a square, it has to be a rectangle and it has to be a rhombus. So like a square is like a very specific thing. It's got a lot of stuff that's going on there to make it a square.